marking scheme at this one. So when you go to page 14 of your tables, okay, you're asked to prove this identity using one of the other identities on page 14. So the simplest one I can find is that tan A plus B equals tan A plus tan B all over 1 minus tan A tan B. Now, on page 13 of your tables, you're also going to see that tan of minus A equals tan A. Therefore, tan of minus B will have to equal, minus tan A will have to equal minus tan B. And the simplest one I found is to replace B with minus B. So replace B with minus B is what you're going to say. And then you're going to have tan A plus minus B. And plus minus is a minus, so it's just going to be tan A minus B. And it's going to feed into this as well, because it's going to be tan A plus tan minus B. And then over underneath, it's going to be 1 minus tan A, and then once again, tan minus B. But when you highlight these two sections here, this one and this one here, they both change into minus tan B. So on top, it's going to be tan A minus tan B. And then on the other side, it's going to be minus tan A multiplied by minus tan B, and two minuses make a plus. And long and behold, you have your proof. Now, that's one way of doing it. I never would have thought of using that one unless I used the marking scheme. Now, the way I traditionally do it, sort of the way the books would have traditionally done it, would be slightly different, but that's the quickest way to get the marks, so we're not going to deny that. Now, I'm going to use a different system. It's good to do both methods, to be honest, but I'm going to use a different system. Here's the system I'm going to use. We all know that tan A equals sine A over cos A. That is a rule on page 13 of your tables, top left-hand side. Therefore, tan B equals, sine B over cos B. Therefore, tan A minus B must in turn equal sine A minus B and cos A minus B. Now, once again, I'm going to go to your tables on page 14, and I'm going to look for the expansion of sine A minus B. Sine A minus B equals sine A cos B minus cos A sine B. Okay. Now, I remember back in the day when I was doing my own leaving cert, I'll do cos A minus B first. So it's going to be cos A cos B plus sine A sine B. Now, the way I remember this is, see the way that's the number 1. Okay, so if you will, the positions are all perfectly aligned. Okay, so this is the way I remember this. This red one here is this red location here. This green location is this one here, because you can clearly see the minus in between them. This purple location is 1. That's the purple location. And then finally, this yellow location is this one here. Now, the one I like to concentrate on is the purple location. What could I do to cos A cos B to turn it into the number 1? Well, if I divide it by cos A cos B, then it turns into the number 1. Now, the problem with doing that is, I'm just going to explain a bit about fractions, right? So imagine I had 5 plus 7 over 9 plus 6, okay? Would everybody all agree that it's 12 over 15? And everybody would be happy with 12 over 15. Now, if I selectively targeted the 9 and said, you know what, it's 9 over 9, that would mean that I'd have to turn that into 6 over 9, I'd have to turn that into 5 over 9, and I'd have to turn that into 7 over 9. I could put all that into my calculator and it'd still come out at 12 over 15. The long story short is, if I affect one part of the question, I have to affect all the other parts in the same manner. Okay? And that's what we're looking at here. Now, what you're going to see happens here, and once again, this will be sort of learned off, is that the cos b's cancel, or they divide into 1. Cos b divided by cos b is 1. Cos a divided by cos a is 1. Okay. Now, here's the trick. What's sine a divided by cos a? Sine a divided by cos a is tan a. What's sine b divided by cos b? Well, that's tan b. And then on the bottom, cos a divided by cos a is 1. Cos b divided by cos b is also 1. So that would give me the number 1. And then finally, sine a divided by cos a, just this part here, that's tan a, okay? And then sine b divided by cos b, that in turn is tan b. Okay. If you're worried about this St. Aidan's, lads, we didn't really go through it that much in 5th year, so just give it a go and don't get too worried if it happens to be a bit on the difficult side. Now, this one, however, should be reasonably handy. Okay. Now, it wants tan 15, and with a lot of these leaving cert questions is they tend to use the equation that comes before. And we would have done these in the book, and the angles we would have used were 90, 60, 45, and 30. And what I can do is I can choose any combination I want to get 15 as my answer. So I only use tan A minus B because that was what we did in part 1. And tan A minus B is actually, one second. So tan A minus B is tan A minus tan B all over 1 plus tan A tan B. Now, what we're going to do is we're going to replace A with 45 and B with 30. You could also do 60 and 45. So anywhere I see an A, it's going to be a 45. And anywhere I see B, it's going to be a 30. Okay, and then it's going to be 1 plus tan 45 tan 30. Now, sort of inclined to, let me see, tan. You could try to do it all in one swoop, like you could do tan 45 plus tan 30. If you do it this way, you'd want to make sure you get it right. And then it's 1, that's a minus on top as well. As I said, if you do it all in one go, you really want to be double checking that everything is correct. And then it's 1 plus tan 45 tan 30. And happy enough with this. Oh, too many brackets there. So limit one of them. There's your answer, 2 minus root 3. Now, is 2 minus root 3 the correct answer? So what I did there was I went direct, okay? But what you're going to see here is that it isn't in the form that it wants. See the way this form here? See the way it doesn't want it like that? So if I was to use my calculator and say tan 15, it is 2 minus root 3, but it doesn't want it broken down completely. So I'm actually going to go back a step here, okay? I'm going to have to do it individually. Tan 45 is actually 1. Tan 30 in my calculator is root 3 over 3. This is going to be interesting. And then on the bottom, it's going to be 1 multiplied by tan 45 is 1. And this once again is root 3 over 3. So it appears I'm going to have to use my fraction skills here. Okay. So it's going to be 1 minus root 3 over 3. And it's going to be 1 plus root 3 over 3. Now, I'm going to give it to top a common denominator. That's going to be 3 over 3. The bottom's going to have a common denominator as well. Okay. And it's going to be 3 minus root 3 over 3 divided by 3 plus root 3 over 3. Bring the bottom fraction upside down and turn it upside down. Bring the bottom fraction up and turn it upside down. That's how you divide fractions. For those you don't remember. If I was to divide, for example, 2/3 divided by 3/4, it's the same thing as 2/3 divided by 3/4. Back in first year, you just flip the top bottom bracket upside down. That's what we did we flip the bottom fraction just upside down. And what's going to happen is those 3's are going to cancel. And what we're going to get is 3 minus root 3 all over 3 plus root 3. And you'll see that that's more in line with the form that we're looking for, I believe. Oh, they want that as minus 1. Even now, right, despite being an experienced maths teacher, right, I haven't done anything wrong, because if I throw this into my calculator, it's 3. This is a complicated old question. It's 3 minus root 3 all over 3 plus root 3. And you only get this by, and I still get 2 minus root 3, which I know is correct, okay? But if I examine my answer, and here's the issue with this question. If I examine my answer, they want it as root a minus 1. They want root a minus 1 all over root a plus 1. Okay? Now, here's what I'm going to do. And you'd only know this as an experienced head. A lot of people weren't getting full marks in this question. See the way there's meant to be a minus 1 and a plus 1. So what I'm going to do is I'm going to divide everything by root 3. And I mean everything. This is a very well designed question, I have to say. Going to divide that by root 3, going to divide this by root 3, going to divide that by root 3, and this by root 3. Root 3 divided by root 3 is minus 1. Now the problem is 3 divided by root 3. You put that into your calculator. 3 divided by root 3. Oh, actually gives you root 3. So that's root 3 minus 1. And then the next one, 3 divided by root 3 is also root 3 plus 1. And that's the form I wanted it in. And I have to say that was a very tricky question, even as a maths teacher. I'd need to practice something like that to get that right completely. All right. We already did that. Now, that was a part 2 question. Now we're on to a part 3 question. So I have a triangle ABC as shown, okay? So the triangle ABC. And I'm looking at this triangle, okay? And it says that AC equals BC. AC equals BC. This means that this is in fact a isosceles triangle, okay? So I can now conclude that this here is an isosceles triangle, okay? And wants to find the length of AC. 2 routes you could go down in. You can't use SOHCAHTOA because it's not a right angle triangle, and you can't use Pythagoras' theorem because it's not a right angle triangle. So those options are gone. When those options tend to go, you tend to have 2 options. You have the sine rule or the cosine rule. Now, what we know is because this triangle is isosceles, it means the 2 right angles are the same. So you do 180 minus 45 is 135 divided by 2, and you get that both these angles here, the right angles are 67.5. 67.5 and 67.5. Now we're after the length AC, which I will now call X. And using the sine rule, A over sine A equals B over sine B. What we can say is that length X divided by sine 67.5 is actually the same thing as 10 2 minus root 2 all over sine B, which is sine 45. Okay, then I'm going to bring the sine 67.5 upwards. I'm going to get 10 2 minus root 2 over sine 45 multiplied by sine 67.5. And I'm just going to give this length as it just whatever number the calculator kicks out at me, okay? So it's going to be 10 root 2. So it's going to be, press the fraction button first, 10 root 2 minus root 2 over sine 45. And then that's sine 67.5. Okay, and the answer is 10. And I know that from the marking scheme. So all good.